Okay, so let's understand database scaling. So to understand database scaling, let's take a very simple example. Let's say you have built a simple e-commerce application for your product, and for in the initial phase, you are expecting around 100 to 500 users. So let's say e-commerce app that you have built, and initial phase, you are expecting around 100 to 500 users, let's say a concurrent users or the maximum users that you are expecting. So for this use case, for this user base, you're definitely not going to create a very big database, right? And here most probably in 99% of cases, you will be going with a cloud deployment. Like you will be choosing any one of the cloud where you will deploy your application, also the database. So here, let's say for this user base, and let's say we are going with AWS cloud. So in this case, what you will do, you will go to AWS, and here you will go to database, that is RDS. And here you will go to databases, and you will just start to create a database. So initially, for the initial phase, as we are expecting around 500 to 1000 users, so for that you will go with a easy create. Let's say you are going with a SQL database, and here you will initially go with a free tier, because for this just 500 to 500 traffic, you don't need a bigger database, and that can be suffice using this configuration, where in a free tier you will get 2 virtual CPU, 1 GB of RAM, and 20 GB of storage. So 20 GB of storage is very high for a simple or initial phase of the application where you have very less amount of data, right? So when you go with this choice, so what you will get, these are the configuration you will get. Along with that, you will get around 50 to 60 concurrent connections. Okay, so initially you will get these connections, that is, at any point of time your database can able to handle 50 to 60 concurrent connections. So that should be sufficient for around 100 to 500 users, because at any point of time we will not be expecting all the users logging in or using the application at the same point of time. And also, if there are concurrent users, then these many connections should be sufficient. Okay, but now let's say your application grows, and now after 6 months, let's say in the second phase, what you will see, you just see the traffic has grown from around 500 users to, let's say, around 1000 to 10,000 users. Okay, so now when the traffic has grown to this number, this configuration will not be sufficient. You will see a very a lot of performance issue. The performance of the response time will get decreased, because it can handle at max 50 to 60 concurrent connections. And now when you have these many users, then definitely you will have more than 100 to 500 concurrent users at some point of time. And in such scenario, this configuration of database will not be able to handle it. So now what you will do, you will go, let's say here I have already created a same database with a similar configuration. So now you will go to your initial database, and here you will go under modify, and under modify you can just change the configuration. So here you can change the instance configuration where you are using 2 virtual CPU. Here you can just go with next 8 virtual CPU or with 32 GB of RAM, and with this you will also get higher storage. So you'll just increase the storage, right? So this is the second phase, where you can just increase the storage, and you can just modify the database, and that will immediately take effect. And with this you can have higher number of connections. According to the RAM of the machine, you will definitely get around 500 to 600 concurrent connections. So with this, definitely we'll be able to handle this load, right? So now this process of increasing the configuration of an existing database, which we call it as vertical scaling. So what we did in the vertical scaling, so initially we started with creating a simple database for our initial use case, where we went with the free tier simple database with 2 virtual CPU and 1 GB of RAM. Now as our user grown and we see higher traffic, so we went with our existing database which we created, and we modified it to the higher configuration, so that we get higher concurrent connections and higher storage that should be able to handle the higher traffic, right? So this process of increasing the configuration and the storage of an existing database, what we call it as vertical scaling. Okay, so I hope you understood about this simple concept. Now the next question will come into our mind when the application grows to the third phase, or let's assume that the application has now grown to the scale of Amazon. Okay, so now in this case, what will happen? So in the third phase, or the phase where it has grown to the scale of Amazon, we may expect around 10,000 to 1 million concurrent users. Now in this case, there will be two things. The first is whether the existing database will be able to store the increased amount of data, and the second, is like whether the existing database will be able to serve these many users concurrently without losing the efficiency or performance, right? So the first question here is that whether the existing database able to store the larger data set. And second is whether the existing database can handle more users with the same performance. So let's first try to answer both of the questions one by one. So to answer the first question, let's take the example of Amazon. Okay, so now if we search for, let's say, total how many products are listed on Amazon. So in the search result, we can see that there are around 600 million products are listed on Amazon. Okay, now here let's try to do a simple calculation. Okay, so this calculation is not exactly related to the Amazon's data, but just on this estimate that there are around 600 million products are listed on Amazon. So now in this case, let's say for each product, it's stored in one row, then there may be around 600 million rows in a table, right? And let's say each row has 15 columns. In 15 columns, they're having different details of that product, right? As we see on an Amazon website, for every product there will be different details. So let's say there are 15 columns and having these details. We are not considering the images or videos because that will be stored in other database like S3 or somewhere that will be referenced back. So here we are just talking about the raw data. So now in this case, we are assuming that there are around 600 million products that will be stored in each row having 15 columns. Okay, and each column is of type varchar, let's say of 200. Okay, so here let's say each column is having around 100 character of data, so that will be equal to around 200 bytes, right? Because every character may hold around 1 to 4 bytes, so let's take an average of 2 bytes. So for 100 character it will be around 200 bytes. Okay, so now if we multiply that 200 with 15, so this is all an average calculation, so then it will be around 3000 bytes, right? So that's the size of data for each row. If you convert that into KB, that will be around 3 KB, right? So around 3 KB of data for each row. Now we have around 600 million rows. So now if we consider 600 multiplied by 3 KB back into bytes, then it will be 1024. And if we multiply this, finally, this will be 600 million. Okay, so here if we calculate this, then we'll get somewhere approximately around 2 TB of data. Okay, so overall, if we want to store around 600 million products data into a SQL database, into one table, then it will take approximately around 2 TB of data. So we are just considering the raw data, not the images and the videos. We're just estimating a simple theory here. Okay, now here we need to answer the first question, that is whether the existing database can store this amount of data, that is 2 TB of data. And this is at a higher side where right now I don't think there is any other e-commerce platform that is bigger than Amazon. So if Amazon has around 600 million products, then that's a higher side. There is no other website or platform where we find more products than this, right? So if you are considering around 2 TB of data, then let's see that whether we have option of this to store this much of data within one database. So here, if right now I'm on Amazon RDS, AWS RDS. So here, if I go with memory optimized classes, then here you can see that if I go for 1024 option for a RAM, then if I select this, then you can see that the allocated storage changes from 20 GB to 65,356 GB. That is nothing but 65 TB. So this confirms that definitely a single database instance can be vertically scaled up to 65 terabytes. That means this data can easily be stored into a single database, right? Where we have a storage option of up till 65 TB. So here the first question is answered, whether the existing database can store the larger data set. Yes, that can be stored. But now here we need to answer the second question, that whether the existing dataset can handle, or the database can handle users with the same performance. Now this is where the things will change on the basis of whether the database has low writes and high reads, or the database has high writes and low reads. Okay, so now what do you think in this case, which one of the option is right? So here definitely the first option is right for this e-commerce platform, especially like a platform like Amazon, because these kind of platforms do not have very high writes, right? So the products are just added only once the product is launched, but the reads are frequent. So every time whenever a new customer or new user logs in, he will be searching for different products. So all those searches are nothing but a read operation on the database. So to handle such a massive reads and such a low writes, we need to go with the next scaling option, that is the horizontal scaling, by doing the by adding the read replicas. So what are read replicas? So read replicas are nothing but the exact copy of the primary database. So once we have created this primary database where we are having all the reads, all the writes. So once we have the read replicas, then all those writes will be automatically get replicated into the other set of databases. Okay. So now why do we need read replicas is how it is solving the problem. So here read replicas will make sure that the load on the primary database gets distributed, right? So initially, now if we take a simple example, then let's say the primary has a concurrent, like it can handle, let's say, around 10,000 concurrent connections. But now let's say during a flash sale, as you know, there will be millions of customers will be trying to shop at the same time. At that time, only one single instance of the primary will not be able to handle such a massive amount of reads. So now how that can be solved? So that can be solved using the read replicas. So with the read replicas, we will be having multiple instances or different instances of the database having the same copy of data. But what that will help? So this will help with the multiple connections, and the load over the database also gets distributed. Okay. So now how do we create the read replicas? Then it's again a very simple process. So if you go to our databases, our existing database, and here if you go under actions, here you will see that it gives us an option that is create read replica. So here we can just add all the necessary details, and then we can just add the which kind of database we need for the replica and all the other details. So once we add this and click on create read replica, so it will just create a read replica, and it will automatically, AWS will copy the data from primary to the read replica, and then we will get a different endpoint for the read replica, and that we need to configure in our application so that all the reads will go to that database that is a replica, and all the writes will be going into the primary. So by this, the distribution, the load get distributed. And here, just for your information, I am using the MySQL Easy Create. That's not a MySQL Aurora that is provided by AWS. So the difference here is when we create the read replica, for every replica we will get a different endpoint, and that we need to load balance in our application logic. But if we go with MySQL Aurora, then here if we have multiple replicas, then for all those replicas we will be getting one single URL endpoint that we can use in our application, where now the load balancing between the replicas will be taken care by AWS. We do not need to apply in logic. Okay, so that's the difference between going with our simple easy create MySQL or going with Amazon's Aurora MySQL database. Okay, so I hope you can experiment on these things. So getting back to this, I hope you are able to understand what is horizontal scaling, where we will be adding multiple instances of the database so that the load get distributed and we get the consistent performance. Okay, so that's the first kind of scenario where the writes were low and the reads were high. Now we have the second scenario where we have high writes and low reads. So for high writes and low reads, we have another set of operations that can be done, that is partitioning and sharding of the database. So next, let's discuss about partitioning and sharding.